Hey, what's going on, guys? Let's do this problem right here. So, first question we have a combustion reaction. The question is asking if 3600 kilojoule of heat is released, then how many grams of CO2 is produced, right? So here, the first thing we have to do is we have to balance the equation. Balance the equation. So whenever we have combustion reaction, we first balance the carbon dioxide, and if you look at the carbon in the left side is 3, right? So we just put the 3 in front of the carbon dioxide, and then we go for the water. So here we have 8 hydrogen in the left side, so we have to put 4 right here, right? And then we count the oxygen, and if you look at the oxygen number, this is 6 right here and 4 right here, so the total oxygen is 10. So we have to put 5 right here. And here they are asking about CO2, and we know that each 3 moles of CO2, 1200 kilojoules is produced, right? So we have to calculate if 3600 kilojoules is produced, how many moles of, how many grams of CO2 are formed. So first we have to calculate the moles of CO2 that is produced, then we convert that one into gram, right? So we are going to go from kilojoule to mole, then mole to gram, right? So let's see how we can convert this one into kilojoule to mole first. So here we know that 1200 kilojoule, 1200 kilojoule. So let's put this 3600 first, right? 3600, 600 kilojoule is produced, and we know that each each 1200 kilojoule, 3 moles of CO2 is produced. So we can say 1200. So we have to put in such a way this kilojoule cancels, right? There are conversion factor. If you notice, there are 2 types of conversion factor. You can write 1200 kilojoule per mole, or 1 mole over 1200 kilojoule. So both are correct. It depends on the situation. Like if you want to convert a mole into kilojoule, this one comes on the top. If you want to convert a kilojoule into mole, this is the correct one, because if you notice the kilojoule and this one has to cancel, so we have to pick up this one right here. And this is not 1 mole, it's actually 3 mole. If according to the equation, for each 1200 heat release, 3 moles of CO2 produced. Each 1200 kilojoule heat is released, 4 moles of water is produced, right? So that's how we do this. So this is 3 moles over 3200. So let's plug the values right here. Here we are going to have 3 mole divided by 1200 kilojoule. Now we have converted this one into kilojoule to mole. Now we have to convert this one into mole to grams. That's the question, right? So we know that to convert mole to grams, we just have to multiply this one by its molar mass. So for carbon dioxide, carbon has 12 grams per mole molar mass, and each oxygen has 16. So 16 times 2, 32. 32 plus 12, that's going to be 44. So we are going to have 44 grams of CO2 per each mole, right? So from this one, if you notice that this mole cancels, kilojoule cancels, and finally we get the answer in gram. And if you convert this one, this is going to be 3 times of this. 3 times 3 times 44. So 3 times 3 times 44. So that's equivalent to 9 times 44, right? 9 times 44 is same as 10 minus 1 times 44. We know that 44 times 10 is going to be 440, minus 44, that's going to be 396, right? So this is going to be 440 minus 44, that's going to be equal to 396. So 396 grams of CO2 is produced when when 3600 kilojoule is released. So that's how we do this kind of problems. Let's look at the second question. The second question is asking to calculate the delta H. This is enthalpy formation of the reaction. So here they have given enthalpy formation for each of these molecules right here, and this is supposed to be in kilojoule per mole, right? This kilojoule per mole. So if you want to calculate enthalpy formation in a reaction, the equation we have to use is enthalpy formation in reaction is equal to sigma products minus sigma reactants, right? Reactants, and that's going to give us the enthalpy formation in reaction. So here if you look at the sigma products, we have products CO2 and H2, so H2O. So we have to add them together. So this is going to be CO2 plus H2O. And sigma reactants is going to be this one, CH4 and O2, right? CH4 plus O2. So let's add them together. So here in the sigma products we have negative 393 plus, and there's a minus right here, so we can directly put the minus. That's going to be O. And one thing before we go ahead and do this one, we have to balance this equation. So let's do the balancing. If you look at the right side, we have one carbon. Carbon is already balanced. Let's look at the hydrogen. Hydrogen is 4 right here, so we have to put 2 in front of this. And then if you put 2, the oxygen also changes. So here we have oxygen 2 plus 2, that's only 4. So we have to put a 2 in front of this oxygen, right? So now it's balanced. Therefore, if you look at this one, we have 2H2 actually. So we have to multiply this one by 2. And in the reactants, we have 2 oxygen. Alright, so 2 H2O mean we have to multiply this value by 2. Right, so here we are going to have 2 times negative 286. And this is going to be plus. And then we have negative CH4, that is given negative 785. Negative 785 for oxygen, right? Oxygen is going to be 0 because oxygen is a poor element and it's in original state. So whenever we have some elements like this, it's always 0 for those kind of elements. So here the enthalpy formation for oxygen is 0, and then that's it. Now all you have to do is simply calculate the value. So here we are going to have negative 393. If we multiply 286 by 2, it's going to be 572, right? So it's going to be minus 572 plus 785, and if you calculate this value, that's going to give you negative 184 kilojoule per mole. And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.